when you have followed my channel during the past days, my idea was to make a square wave oscillator with field effect transistors. And it took quite a long time. It did not succeed at first sight. Finally, I made a circuit that worked with two MOSFETs, and that also tells something about one of my videos that I published a few days ago. That was the transistor tester, universal transistor tester for MOSFETs, small signal FETs, bipolar transistors, etc. etc. I will try to give the link in the text box. So I searched on the World Wide Web and I found this beautiful chip from Texas Instruments. It only costs €1, at least in Europe, and the type number is this. So now it's on the breadboard, the well-known way that I make my circuit with brass nails. There are a few potentiometers, and here is the schematic. I hope it's visible from this distance. The voltage supply must be approximately, not approximately, but 5 volts. It is a chip that also can serve TTL logic, though it is CMOS logic anyway. I made a 5-volt power supply here in a standard way with the 7805, and that's here in the circuit. I have by purpose showed all the earth connections separately to make the whole drawing not too complicated, but slowly pan over now. There are a few pins of the chip that are not used. And of course I've studied the data sheet from Texas Instruments. These are the pins that are not used. This is a voltage controlled oscillator, but also a phase locked loop chip. I cannot tell you something about a phase locked loop IDs, properties. I don't know anything about it, but I only wanted to use the voltage controlled oscillator part of this chip, and that was successful after all. Again, the schematic, don't want to forget that. And there are a few very peculiar things that I found out. At first, that when there is no voltage supply to the chip, this switch is open, the whole circuit oscillates. So I think, don't know that for sure, that the voltage to that chip comes along here via the VCO in. And when you study the data sheet, you can surely see that VCO in. Well, that could be, but there's also the so-called VCC. That's the standard indication when we are talking about TTL chips, CMOS chips. That is the supply voltage. That's why I've made here a switch, and there are more things to tell. This capacitor is responsible for the frequency, but also these 3 potentiometers are responsible for the frequency. But when the chip is not served with VCC, that is a supply voltage, they don't work. These ones don't work, but this one works, and you can set the frequency. So here it's on the breadboard. the 7805, the 3 potentiometers. Of course you must be careful not to make the voltage on pin 9 too high. According to the datasheet it is maximum 5 volts. That's why I've used here a voltage divider. Anyway, let's see what happens. Now, by the way, there's no connection to the VCC pin 16 is not connected. So the chip, as far as I can see, only receives its voltage via that pin 9. And we have here a very good waveform. No problems with that. And when you turn that voltage on pin 9, let me do that, you see that the waveform, the frequency changes. So here so we have here now, of course that depends also on the capacitor, we have here 15 kilohertz, kilocycles, and we have here a capacitor of 1N5, that is 1500 picofarad. We have a beautiful waveform, etc. Lowest frequency is now, without VCC, it is 25 Hertz. No, sorry, not 25. Here it oscillates. That is 2.4 kilohertz. Anyway, let me show now what happens when we add voltage to the circuit. I do that with this switch here. So now we have an enormous say other situation. I have to get my scope to other settings. And now we are, when we have added voltage to the chip, so now this switch is closed. We have 5 volts here on the chip. We have this waveform, and you can surely see that there's a lot of ringing. I have to study that better. Perhaps I have to make a filter or a few filters anyway. But the good thing is that it is on 1.6 megahertz. And the capacitor is 1500 picofarad. And now these 3 potentiometers here work. This one and that one and that one. And these are these 3 potentiometers. This one, that one and that one. And here we set now, because it's a voltage controlled oscillator, here we set now the different voltages via that voltage divider. And that means that the frequency changes when we turn this potentiometer here. And also this one and also this one. I have to study that much better. But of course you can do your own experiments. I'm always interested. When you have other conclusions, better solutions, etc. etc. Anyway, it's now 1.6 megahertz. With all that ringing here, I have already made a first filter. I could remove that ringing a little bit. Anyway, turn now the potentiometer on pin 9. Let's see what happens. So the oscillator works now from 500 kilohertz up to 1.6 megahertz with that 1.5 a nanofarad capacitor that is 1500 picofarad capacitor. That's a good result, I think. I'm gonna turn out the two other potentiometers, and now we see the whole circuit drop down in a certain way. Oh well, this is still okay. 2 megahertz, 2.2 megahertz, 2.9 megahertz. Well, I had not expected that it was so good. Anyway, though the ringing is still here and it smears out on the screen on the higher frequencies. So for the higher frequencies the ringing surely is a problem, at least with this setup. To the other potentiometer now, that is the potentiometer on pin 11. Well, here we see the whole circuit more or less drop down. It gets a kind of sine wave, etc, etc, and we are on 40 megahertz. Well, could be true, could also be, say, an harmonic or so. Anyway, I don't know that. So let's go back to the situation where it works properly, more or less properly. Anyway, here I show how you can test such a circuit and how you can use such a beautiful chip with such good properties and at the same time very cheap. In the Netherlands I pay €1, say $1 for this chip. Change the capacitor now to 100 nanofarad, a frequency dependent capacitor. Turn the... well, anyway, I think it was a good demonstration. Do your own experiments. That's also one of the aims of my YouTube channel. Do your own experiments. Try, test, etc, etc. So, thanks for watching. I cannot make this video too long. I'm now on 12 minutes. You have seen the waveforms and they were very good. The phase locked loop part, of course I didn't use it because I don't understand how the phase locked loop works in practice. Of course in theory I know it, but in practice, and that's the whole aim of my channel, practical things that work on the breadboard, etc, directly usable for electronics hobbyists or perhaps even professionals. Well, so the schematic again, very slowly. I will try to get that beautiful square wave back again, though perhaps it will not succeed, but anyway, let's try. Well, this is more or less okay. And again we see here the ringing. There must be a cure for that ringing, I'm absolutely sure. And well, thanks for watching again. It's a beautiful chip with many possibilities, and it's also very cheap, so you can make a good quality square wave oscillator with it, working from say 1 kilohertz or 50 hertz up to say 1.2 megahertz or even higher. But that needs more study.